this is still Unit 1, Part 4. I'm going to do the second half of it because my camera decided to get fuzzy. So let's talk about congruent angles. We already talked about that the word congruent means same size, same shape. So if measure of angle A is equal to the measure of angle B, that means they have the same degrees in them, then the angles are congruent. It is written as angle A is congruent to angle B. We use that little squiggle over the equal to mean congruent. Since these are both 75 degrees, they have the same measure, they are congruent. So let's define angle bisector. We did segment bisector. Angle bisector should be pretty easy to figure out. That it would be a ray. It's usually a ray. It could be a segment or a line, but for our purposes, it's usually a ray that divides an angle into two congruent angles. In the diagram to the right, do you see ray BD that goes in the middle of this? Ray BD is an angle bisector. Therefore, that means it bisects, it cuts the big angle in two. Therefore, angle ABD, do you notice up at the B, the vertex in the middle, is congruent to angle DBC. Now look what I did here. I've got ABD, that's right here, and then I have DBC, that's right here. So I had to use the D to name them. They are congruent because they have an angle bisector. So two lines, this also should be reviewed to you and not new. Two lines that intersect at a right angle are perpendicular. So, like I said, this should be a review for you. Two lines are perpendicular lines if they intersect at a right angle. Now, it actually makes four right angles. So, if these lines intersect and this one's a right angle, then you know that all four have to be right angles. The symbol for perpendicular is like that, like an upside down T. And then the diagram to the right, here's an L and an M. Remember there's lowercase, cursive, italics things. In the diagram to the right, line L is perpendicular to line M. The way we know that is it makes right angles. Once again, we can't assume, we can't say it looks like a right angle. We have to know, and we know because they gave us the little square in one of them. So, perpendicular bisector, I hope we're getting good at that word by now, is a segment line or ray that is perpendicular to a segment at its midpoint. Therefore, if it's perpendicular at its midpoint, it's going to cut it into those two congruent pieces. This tells us it's perpendicular. So, in the diagram to the right, this one, line LM, remember line symbol has two arrows on the end, is the perpendicular bisector of segment PQ. It cuts it into two congruent pieces. All right, let's look at a little terminology here, and we've got a bunch of angles going on in this picture. Write another name for angle, CBF. Okay, C, remember vertex is in the middle, the other points are on this side, CBF. What else could I name it? I can't name it angle B because there's too many angles going on here, but I could name it in reverse order, FBC, as long as that vertex is in the middle. Its sides, the sides of EBD. EBD. The sides of angle EBD are ray BE, remember vertex has to go first, and ray BD. And put the little symbol with one arrow. Classify angle ABC. Well, do you see how this is a straight angle? Therefore, since this is a right angle, we know this is a right angle. Meaning this one. I wrote the wrong one. Gotta watch me. Sometimes I look at the wrong one. ABC. I read ABD. ABC is a straight line. Therefore, it is a straight angle. How many degrees is a straight angle? 180. Just to make sure you remember that. Give an example of an obtuse. Obtuse has to be between 90 and 180. So I have choices here, but I see this one. If I took this right angle here and kept going over here, then an obtuse angle would be angle EBD, which we looked at before because we named its sides. Name two congruent angles. Well, I already pointed out to you that these were both right angles, therefore they're congruent because they have the same measure, so I can say angle ABD and angle DBC. Name a perpendicular bisector. Okay, which ray liner segment is perpendicular to another ray liner segment, or actually just segment, cutting it into two equal parts? Well, that would be ray BD. It cuts this line right here, or this segment actually, into two congruent parts. They're marked. I drew all over that, but if you didn't draw all over yours, you should be able to see it. Okay, I'm going to skip this for the sake of time, and I am going to do the last page of 1.4 notes, which is angle addition postulate. If D is in the interior, so that would mean the inside of the angle. So if it's in the interior of ABC, which ABC is my big angle right here, D's in the middle of it somewhere, then the measure of this angle, ABD, plus, I'm going to put that right there, plus the measure of this angle, DBC, is going to equal the measure of the big angle, ABC. Once again, just like our segment addition, this makes sense. It's part plus part equals whole. So on this one, if ABD is 48 degrees and DBC is 78 degrees, what is ABC? Well, just add them together, 126 degrees. Let's skip down to this one and do some algebra. We got some x's in there. Find the measure of angle PQR. Nope, not find it. If the measure of angle PQR is 141, find each measure. Now remember, part plus part equals whole. So we can always do part plus part equals whole, or whole minus part equals part. 13x plus 4 plus 10x minus 1 equals 141. Let's solve this. I've got 23x plus 3 because I put those together, and then I put those together. And then I'm going to take away the 3, and I'm going to divide by 23, and x is 6. Now I have to find the measure of PQS. Well, it's right here. Plug in 6 for x, and I get 82 degrees. And then, which one do I need? SQR. Now, if I've done it right, I should just be able to go 141 minus 82. And that should be the same thing I would get if I plugged in 6 right here, which it is. I believe this video is long enough, and I think you've gotten the point.